Hi, I'm Bob Tabor with Developer University. For more of my training videos for beginners, please visit me at devu.com. You might recall at the outset of this course, I said that a class is a container for related methods, and I used the console class as an example of this. We had the console.writeLine, console.readLine, console.write. We even used console.clear. All of these methods that had something to do with working with a console window, and so I said it makes sense to put them all in the same class, the console class. Now, truth be told, I intentionally oversimplified my explanation about classes and their relationship to methods because, first of all, I wanted you to gain a little bit of confidence in yourself that you can do this, that this isn't hard. You can get your hands around it and you're going to do just fine. And I wanted to do that before we got into the topic of classes because while there's nothing hard per se about classes, they do lend themselves to a conversation about object-oriented programming, a style of programming that some beginners find a little bit difficult to grasp at first. Now, the code that you've been writing in your methods have all been defined inside of classes, right? And you've been calling methods that were defined inside of classes, right? Classes have been all around you. You've been working with them up from the first line of code that you wrote. So you're really already an old pro at this, whether you realize it or not. I'm merely going to fill in some of the details that you don't yet know about in this lesson and in a couple of subsequent lessons so that it rounds out your knowledge so that you can fully harness the power of the .NET Framework class library in your applications. Yeah, okay, maybe someday, whenever you sit down to architect some big application for some large company that you go to work for, you'll begin to think like an experienced object-oriented software developer. But at this early point in your C# experience, I really just want you to be able to do one thing and one thing well. That is to find what you're looking for in the .NET Framework class library and be able to have the confidence to utilize the methods and the properties in those classes that have been defined there. All right. So the truth of the matter is that object-oriented programming is such a massive topic that I certainly couldn't do it justice in this course. In fact, I have a whole course devoted to it on devu.com. Again, I really just want to accomplish one thing here. I want you to know enough about classes and objects and properties and methods and things like that so that you can harness the power of the .NET Framework class library inside of your own applications. Now, the way that we're going to learn about classes and methods and properties and all that good stuff is by creating simple custom classes of our very own. So let's start by talking about creating a simple application for a car lot. So suppose that I own a car lot and I want to sell cars. And I want to build an application that helps me keep track of all the cars on my car lot. So I might need to create a number of variables to hold information about a given car because I'm going to use that information to then determine its value based on its make and its model and its year and so on, right? So I might start off by creating a couple of variables called car1 make, car1 model, car1 year, and so on in order to keep track of that information. Now, what if I need a second car in my application? Well, then I guess I could create another set of variables called car2 make, car2 model, car2 year. What if I need a third one? Well, I think you see where I'm going with this. Things are going to get out of hand pretty quickly here. Then what if I decide one day that the value of the car is not only based on the make, model, and the year, but we also need to keep track of the color of the car as well. So in that case, now I got to do a car1 color, car string, car2 color, and so on. All right, so you can see that this simply is not the right approach to keep track of information that should be collected together about a given entity. So I need a way to keep all of this data about a car kind of together in its own little container. I want to keep track of the make, the model, the year, the color, and maybe a bunch of other things too about a single car. But I don't want to have to treat it like a bunch of loose information. I need it all kind of related together. So what I'm going to do is start off by defining a class that contains 4 properties that describe any given car on my car lot. Okay, so to begin, what I'm going to do, you can see I have a project that I've already started with here, simple classes. Go ahead and pause the video and catch up with me if you like. And what I want to do is work actually outside of the first class that's already been defined in our program.cs file. So I want to work inside of the namespace simple classes, but I don't want to define a new class inside of my existing class. I want to work outside of that class here. And so I'm going to define a new car class like so. And I'm going to give it 4 properties, and I can type it all out like this, and I'll explain what I'm doing here in just a moment. Or I can use a shortcut, prop, tab, tab, and then I can use the replacement, the little replacement areas by using the tab on my keyboard. So I want to make a string, tab, tab, model, enter, enter, prop, tab, tab, int year, enter, enter, prop, tab, tab, string, tab, tab, color, enter, enter. Okay, so I've just defined a class named car with 4 properties. This car class allows me to define a data type that describes a car. Every car in the world. Every car has a make, a model, a year, and a color, and a bunch of other information that I might or might not be interested in for my specific application. But my aim here is to use this definition of what comprises a car in order to create additional instances of the car class that represent all of the cars on my car lot. Okay? In other words, I want to create a bucket in the computer's memory that's just the right size to hold information about any given car on my car lot. So it should contain not only the fact that it's a car, but then also the value of its make and its model and its year and its color, all kind of in one big bucket up in the computer's memory so that I can access it. All right. So there's 2 parts to this. There's defining the class itself, and then once I've defined it, I can create instances of that class. So here the class is the definition. But when I create a new instance of this class, then I'll be working with an object, and sometimes those terms get confused. But the class is the blueprint. The object is an instantiation or something that's been created as a result of having the blueprint or the pattern. Okay? So the way that we create a new instance of the car class is to do this. I'll just call this my car to avoid confusion. So at this point, I've defined it just like any variable I would by declaring the data type itself, whether it be string or integer. This is just a little bit more interesting, a little more complex. It's the car class. And then I give it a name that I want to call it by, my car. All right. Now that's part of what I need to do. The next thing that I want to do is actually then create a new instance of that class and say, put this up in the memory, in the bucket, so to speak. So here we go, new car. All right, so again, there's 2 parts of this equation. We'll talk about this more as we go throughout this, this course. But we're saying, first of all, I want to declare a new car in memory, and then I want you to actually create the car. I want to create an instance of car and then put it up in the memory. So there's 2 distinct steps there. All right. In the real world, you can use the same blueprint to create many different houses, right? You could, like in the neighborhoods that I've lived in before, you might describe them as cookie cutter houses. They all look the same. You could use the same pattern to create clothing over and over, or you could use the same recipe to create the same cake or casserole and get the same results each time. So each time you want to build a new house, it will be at a different address, right? Each time you follow the pattern, you'll create a new instance of the clothing that can be sold to a different customer. Each time you follow that recipe, you'll create a new instance of the recipe, and you can offer it during either the same meal or a different meal. All right? And the same is true with classes. Each time that you create a new instance of the class, you have a new object that is distinct and separate from the other instances of that same class in the computer's memory. All right? So they each live by themselves. So a class is like a cookie cutter. Now, keep in mind, you can't eat the cookie cutter itself, right? You eat the cookies that you make from the cookie cutter. The cookie cutter gives each of the cookies some shape, and so when you instantiate a new instance of a class, you're basically using your class as a cookie cutter to stamp out new instances, and you have 1, 2, 3, 4 new instances of cookies that you can then put in the oven and bake. All right. So focus on the new keyword. It is what you would consider to be the factory. It actually builds the new car and puts it into memory. All right. It uses the blueprint. It uses the pattern. It uses the recipe, uses the cookie cutter in order to create a new instance of that blueprint or that pattern or that recipe or that cookie cutter. And it brings the class to life in the computer's memory, and it makes it usable by your application. And you can create many instances of a given class, or you can create many objects all based on the same class, but each object will be distinct from the others, if by no other distinction than by merely the address in memory where they live. Okay, so what I want to do is not only set the properties of this car, because I have these 4 properties that I want to use to distinguish this car on my car lot, to represent this single car, but then also I may want to then access or get those properties back out. And it's working just like you're working with variables, all right? So in this case, instead of just accessing make variable, I would go my car.make, right? And I would set that equal to like Oldsmobile. Now, admittedly, in this particular case, I am merely hard coding these values. If this was a real application, I would ask an end user to input this information, or I'd grab it from a database or something along those lines. All right, so there we have it. We have one instance of the car class, and I've set all of its properties, and now I want to get those properties and print them out in a console window. And we'll just do this in the most easy way possible. And we access, or we get the values just like we set the values before, by using the name of the object dot the name of the property. So let's go make my car dot model, my car dot year, and my car dot color. Now you might be wondering, well, Bob, why did you do it that way and not car.make or car.model? Remember, car, in that instance, car, describes the class, the blueprint. But what we want to work with is one instance of the blueprint. So that's why we're calling that instance my car. It's the variable name in the computer memory that we want to work with. So let's go ahead and separate these out onto separate lines, and then finally we'll go console.readline, like so. And this should not be an exciting application at all, because we're merely just printing things to screen, okay? But at least I can show creating a new instance of a class, setting the properties, and then getting the properties and printing them out. So that's what this get and this set are for. And there are actually longer versions of to declare a property. In fact, let's just do this prop full tab. And so this is a longer, more complete version of creating a property, but I don't want to talk about it right now. There are reasons why you would want to use this, but for the most part, for our simple needs, we'll just use this abbreviated version of defining a property in our classes, okay? Now, did you notice that we got full IntelliSense support? So whenever I typed out my car dot, and I use the member accessor operator, then I'm able to see all the members of the class, the make, the model, the year, and the color, all represented as little wrench icons in IntelliSense so that I can access them, whether to set their value or get their value. Okay. Furthermore, I'm able to set values the way that I would just with normal variables by using the assignment operator. Okay. I'm able to work with the variables and write them just like I would any other variable in my system. Okay, so there's nothing all that special about it outside of the fact that they're all related to a specific instance of a class. So we've created a new data type, the car data type, and since it's a data type, we can use it just like we would any data type in our system. So if I wanted to create a little method here, private static, and I'll use the decimal data type because I'm working with going to work with dollars or money, currency, and I'm going to create a method called determine market value. All right, and I'm going to allow this to accept a car as an input parameter. And what I'll do is just, in this case, I'm just going to hard code car value to $100. Okay, and we'll leave it at that. In fact, I'll go ahead and add the M here. However, if this was a real application, someday I might look up the car online using some sort of a web service to get a more accurate value. Okay. Accurate value, but for today we're just going to hard code the value to be 100 and we'll return car value. Okay, and so here I can go determine market value. I can pass in my car and I should return back a value. So let's go decimal value equals determine market value, and then let's go console.write line, and we'll use what we learned previously to print out the value of the car, like so. And let's run the application. And you can see that it's worth $100. All right. Now notice what I did here. I used an uppercase C in car and a lowercase c in car. The uppercase C corresponds to the name of the class because I named it with a capital C. And the C# compiler is smart enough to know that, again, capital C car and lowercase c car are two different things. And this is a common naming convention to use the same name for an object if there's no reason not to, if there wasn't something special about the car, like it being in some special state. But I can reuse the word car. I chose not to do that here just to make it obvious what I was actually doing, but there's nothing wrong with doing this as well, defining this input parameter's data type and then giving that input parameter the same name but just with a lowercase character. They're two very different things. Okay, so moving on, I want to talk about creating methods on the class. We've already said that that classes are containers for methods. So we've created this helper method here inside of my static void main, but it might make more sense for us to create that method here inside of the car class itself, since the car class already has access to information like the make, model, the year, and the color, right? And that's the kind of information that we would use in making a determination on its value. So here, let's go ahead and define this as a public decimal determine market value. Now we're not going to allow anything to be passed in because we already have all the information we need right here. Okay, so let's create a little algorithm here. So if the year is greater than 1990, then we will set the value of the car's value, which we need to define as a, so let's go decimal car value. We'll set the car value equal to $10,000. So if it's a relatively new car, we'll set it to $10,000. Otherwise, we'll say the car's value is only worth $2,000. All right. So this is a very, very overly simplistic example, but we just want to demonstrate the fact that inside of an instance of the class, you're going to be able to access its properties. Okay. So we're able to access the current car's year in order to determine its value. And so in this case, what I'll do is let's comment this out. And comment that out. And here we'll go console.writeLine mycar.determine market value, like so. And because this is going to come back as a decimal, I'm still going to want to format it. All right. So now let's go ahead and run the application. All right, and since it's in 1986, it's before 1990, it's only worth $2,000, okay? So in this lesson, we used a very concrete example. We've all seen cars, driven cars, owned cars, okay? A car is easy to conceptualize and represent in a class because there's a tangible real-world equivalent. Now, my assumption again is that your main exposure to classes will be whenever you're using classes defined by Microsoft in the .NET Framework class library. And most of the time, those classes don't represent real tangible things. They're very conceptual in nature. You might have a class that represents a connection to the internet. You might have a class that represents a buffer of information that's streaming from a hard drive, okay? They don't really have real-world tangible equivalents, so you need to be aware of that. In most cases, the .NET Framework class library classes don't have real-world equivalents, but the ideas are exactly the same. As you mature as a software developer, you might want to invest a little bit more time in learning how to create your own library of classes. And those classes can interact with each other. They can represent real things in your company or in the real world or conceptual things. The process that you go through to break down a problem in the real world and represent it in objects is object-oriented analysis and design. Again, that's not a topic that we're going to cover in this series of lessons, but you can learn more about that at devu.com, where I spend a lot of time talking about those sorts of things. Okay, so to recap, a class is just a data type in .NET, and it's similar to any other data type, like a string or an integer. It just allows you to define additional properties and methods. So you can define a custom class with properties and methods, and then you create instances of those classes. Or rather, you create an instance of a class, therefore working with an object using the new operator. You can then access that object's properties and methods using the dot operator, the member accessor operator, right? So there's quite a bit more to say about classes. Don't worry if you don't understand everything just yet, why you even need them, how to really fully utilize them. Just make sure you understand the process that we went through in this lesson of defining a new class, creating an instance of a class, setting its properties, getting its properties, passing an instance of a class into a method, or even defining the method inside the class itself and allowing it to access its own members, like its other properties. Okay? So if you really don't understand much more than that, then you're doing just fine. You're exactly where you need to be. Don't worry. We'll cover lots of other topics related to this in the upcoming lessons. We'll see you there. Thank you.